Any line can be written in the form y is equal to mx plus b, where m is the slope and b is the y-intercept, and in fact, we call this form the slope-intercept form for a line. If we look at the graph, it's definitely a line, so from this we should be able to determine the y-intercept and the slope if we know a couple of points on the graph. So to start with, it looks like the y-intercept is here. This is where the graph is on the y-axis, so I'm going to mark this. And b represents the y value of this point, so off to the side I'll put, well, okay, b is going to be equal to 4. So as a point, that would be, well, 0 comma b is the point 0 comma 4. Also, I need to know what the slope is equal to. And we can use a couple of points to figure that out as well. So maybe I'll draw a second point. It could be anywhere, but how about this one? If I know these 2 points, I can use the idea of rise over run to determine the value for the slope. In this case, we are going over 2 and up 4. That means the slope must be 4 over 2, or just maybe simply 2 over 1, or 2. If you know these 2 values just by looking at the graph, we can write the equation y is equal to 2x plus 4. And that would represent the graph for this line. So maybe just verify that this is in fact true. We'll set up a table of values and choose some numbers for x and solve for the corresponding y values. If you use x is equal to 0, that means you're putting 0 in place of this x. 2 times 0 is 0, and we're left over with 4. So that explains why, okay, the number at the end, b, is going to be the y-intercept, because you're putting 0 in place of x, and 4 is the only thing that's left over, that it's telling you the location of the graph on the y-axis. If we plug in a couple of other points, so maybe we can plug in 1 or 2. If we plug in 1, we get 2 plus 4, which is 6. If we plug in 2, we get 4 plus 4, which is 8. Okay, so it makes sense that the number in front of the x tells you the slope. It's telling you that, okay, every time you increase this by 1, this is going up by 2. So this value represents the slope, and this value represents the y-intercept. If you're asked to find an equation of a line, you just need these 2 things. So one reason the slope-intercept form for a line is nice is because it simply tells you what the graph looks like. So here we have a line 2x minus 4y is equal to 6. So this is not written in the form y is equal to mx plus b. If it were, we could immediately identify the slope and the y-intercept. So any line, like this one here, we can solve for y to make it look just like this. So let's try it for this example. We have 2x minus 4y is 6. To solve for the y, I need to first, let's say, subtract 2x from both sides. This gives me negative 4y is equal to, and I'll write it as negative 2x plus 6. I'll now, okay, I gotta get rid of that negative 4, so I'm going to divide negative 4 to both sides. They cancel on the left, so I'm left with just y. Now on the right, that negative 4 is divided into both terms in the numerator. So here I have negative 2 divided by negative 4. The negatives cancel. 2 over 4 is the same thing as 1 over 2. So I'm going to put 1 over 2x. For the last 2 terms, okay, I have a positive over a negative, so I know I'm going to end up with a negative number. And okay, we have 6 over 4. And we can simplify this a little bit. This is 1/2 x minus 3 over 2. So if we want to use this to graph the equation, the original one, this brand new form, I'll just note that, okay, the slope is 1/2, and the y value for the y-intercept is negative 3/2, or maybe just negative 1.5 if you'd like to use a decimal. I'll start by marking the y-intercept. Okay, so that is negative 1.5, so that's about here. And if we use slope, slope means you go rise over run. So this is, I'm going to go over 2 and up 1. So maybe I'll get a second point on my graph. I'm going to go over 2 and up 1. So I have this spot here. That is 2 negative a half. And you can use this idea to get several more points on your graph if you'd like. So again, you'd go over 2 and up 1. But just with these three, I know what my equation has to look like. It is the line that's going through those 3 points that I drew. So the idea here is if you transform your line so it looks like m times x plus b, it's easy to visualize the graph. You can start by plotting this number, which I put right here, and then use slope to just get a second point on your equation. And once you have those two, you can just draw the line that goes between them. Okay, so for example 2, same question where I'd like to find the equation of the line. I want to find something that is of the form y is equal to mx plus b. But this time, I'm just given 2 points, negative 2, 7, and 1, comma 2. Between any 2 points, you should be able to draw some line. As long as it isn't vertical, you can write it like this. I think I'm going to start by just plotting these 2 points to think about what the line would have to look like. If you have negative 2, 7, I know one of the points is here, and the point 1, comma negative 2, 1, negative 2 is located here. So whatever the formula I'm looking for is, it has to give me something. I'll try to sketch it carefully, but something that goes through those 2 points like this. So, I know a few things about this line already. I mean, I don't know the exact value of the slope. Like, I don't know what that is, but I do know that it's a negative number. It's definitely something that's less than 0. This line is decreasing, and by quite a bit. Also, my sketch isn't very good, but I know the y-intercept has got to be around maybe like 1 or 2 or 1.5 or something like that. So I at least have an idea of where b is located. It's going to be some positive number. I don't know, maybe it's about 1.5. I don't really know for sure exactly, but I have my graph. I should be able to figure out these 2 items. And once I do, I can put them in place of m and b, and I'll have my equation. So let's start with, all right, I guess I'm going to figure out the slope first. So starting with the slope. And you could count this right off of the grid, but maybe I'll just plug this into the formula for slope just to, use this. We haven't used it yet this lesson. All right, I'm going to label my points. I think I'll call x1, y1. Maybe I'll use negative 2, 7. And then x2, y2, I'll use 1, negative 2. If I plug that in for slope, y2 minus y1 is negative 2 minus 7. And then x2 minus x1 is 1 minus negative 2. If I simplify this, okay, I get negative 9 over, that's 1 plus 2, positive 3. So that is negative 3 over 1, or just negative 3 represents my slope. And if I kind of go back to my line here, okay, so if I go down 3 and over 1, I mean, yeah, okay, that kind of looks about right. I know it's not a perfect sketch, but okay, I'm feeling like that's good. That negative 3 is the slope. I'm going to go back to my equation, put negative 3 in place of m, and the only thing that I do not know is what is the value of b. If I know what that number is, I've solved this problem. So that's my goal. I have m. What is b? So to figure out b, I have 2 pieces of information that I can use. I have this point and this one. It turns out it won't matter which I use, but I'm going to choose this point. I'm going to plug this information into this equation. Here's what that means. The point 1, negative 2 means x is equal to 1 and y is equal to negative 2. If I substitute that in, I get negative 2 for y, And then for x, I get 1. And that leaves me with b, the only thing that's not solved for yet in this expression. So if I simplify this, I get negative 2 is equal to negative 3. Adding 3 to both sides gives me 1 is b. Okay, so b is actually the value 1. If I go back to my equation, I know the slope was negative 3, but I know b, if I want to be more precise, so that's actually right here. It's y is equal to 1. This formula is the equation of the line that goes through the points negative 2, 7, and 1 comma negative 2. You could even plug that information in here to check to see that it's true.